So looking at this inequality, x squared minus 3x plus 2, we want to know where the critical values are. And the critical values are going to be where the zeros are. So if I just click on that, okay, so I'm going to have zeros at 1 and negative 2. So I'm just going to zoom in a little bit here. Okay, so there's 1 and negative 2, 1 and 2 represent my two zero values. Okay, so if I want to solve this, I want to know where this inequality is bigger than 0. I could test the boundary regions for the one variable x. X is 0, and I can see that x is 0 does seem to fit if I plug in 0. Okay, and then if I plug in a number between 1 and 2, like 1.5, it probably will not fit. And then if I plug in numbers like really big numbers, so for example, 5, I get 25 minus 15 plus 2. Again, that's bigger than 0. So I can show the quadratic equation as well. And I can see the quadratic equation. This part of the graph is above the x-axis. This part of the equation is above the x-axis. So this inequality, the solution, should be the part on the x-axis that is above the x-axis here. And then I can see that the inequality then is true. Yeah, anything less than 1, okay, on this side, or anything bigger than 2, everything on this side. And you can see that that represents a part that is above the x-axis. The part below the x-axis is not part of my inequality. So if you look at these, if you look at the input and outputs, okay, if I let x equal 0.89, it's on that side, so you can see that the output is going to be bigger than 0. If I move this along, I'm not too sure if I can move this along, but if I move this along into the other regions, you'll see that the output of the quadratic is going to be negative, which is less than 0. Okay, so again, I can't quite move this, but that's the point of this animation.